Welcome to the second game dev video update. Before we get the ball rolling, I'm going to need to point out that this time we're not actually looking at the Breakout game I was making, but instead we're looking at something else that I made for a class at the end of the semester. It's really small, but it's a game nonetheless. The first thing I want to point out is that Matlab is not a game engine. It's not built for game making. You can do things like this, really simple stuff, but the only problem is if you do larger stuff like an actual game, it slows down. What Matlab is good for is it allows you to do a lot of testing, really on-the-spot experimentation with programming and different things like that. And you can do a lot with graphics and testing out how graphics things work before you import it to some other language like Java, C, whatever. Anyway, for the game I made, I call it Geo In Mazeland. It's a little maze type game. You have a little character and you have a little 3D maze that you're trying to move them through and basically get from start to finish and you win. Simple as that. There's only one level. There's one last thing before we head into the demo that I wanted to point out, is that this game I completely programmed from scratch. There's nothing that was already there like I had in my Breakout game in Game Maker, where a lot of the features were all there. I just had to click buttons. No, I had to type this. All 258 lines of code that went into this was typed by myself, and that's the difference between programming a game and designing a game. When you program a game, you have to do everything. There's, you know, how the character moves, they react, whatever, what have you, whatever you want the character to do, has to be programmed in by yourself. There's nothing to help you do that in like a game engine. But that's enough of me talking about it. Let's get to the demo. Alright, so I just ran the game through Matlab, and if you usually have anything graphic-oriented or anything dealing with graphics or whatever, graphs, what have you, this window usually pops up as a figure, and we can see that we have our little maze here, and we have our character Geo. Your purpose is to get him from the start position here to the exit position, and to do that you use our little controls down in the corner here. I could have mapped them to actual keys like WASD or the number pad or the arrow pad, but I didn't really feel like it. So anyway, you can easily move the character. He goes in the direction that you move him in. If you try to move him to an obstacle like say this lava, he won't go anywhere. He won't turn. He just will not. Who refuse to go wherever he wants, wherever there's danger, basically. Anyway, you can continue moving him through the maze. And as I'm doing this, I'll explain a little bit. A lot of what is going on behind the scenes in the program, which I'll explain a little later, is matrices, or matrix. They are basically a set of numbers, but I'll explain that later. And they are determining where he is in the maze, where obstacles are in the maze, how he's moving through the maze. Just everything, almost everything about this program is almost run entirely by matrices. But anyway, he's getting to the end. He finally finds the end, he gets to the exit, and we have a you win. And that guy in the little window is actually my professor to congratulate you on beating my game. And all you do is click the OK button, and that's it. There's really no like restart or anything like that. I mentioned something called a matrix. And for those of you unfamiliar to what a matrix is, and no, I'm not talking about the movie series starring Keanu Reeves. It's a set, basically, simply, it's a set of numbers. It's usually arranged like an array. I'll show you later. And it can do many different things. For example, in my situation with the game, the biggest thing the matrix can do for a program is govern how transformations occur and what transformations occur. Now, when I say transformation, I'm talking about, in our case with Geo, like translation, rotation. You can have things like reflection, skew, scale, stuff like that, that governs the way a shape acts in space, either 2D, 3D, and it's either going to be 9 numbers dealing with that, or there's going to be a 16 number 4x4 or 3x3 matrix dealing with how the coordinates change based on how you want the object to transform. Another place in the program where matrix shows up is actually in the creation of the maze. The entire maze is actually, on the whole, a matrix with different numbers in it that correspond to what shows up in a specific square, either flat ground, lava, the start or end positions, or the little spikes, the obstacles. So I wanted to give you guys a little bit of a idea of what I was talking about before. This matrix is what governs the maze. It's a variable called maze mat, and everywhere you see a 0 means an obstacle, those little spikes. Everywhere you see a 1 means a walkable path. Everywhere you see a 2 means lava, and every time you see a 4 means the start, and the 5 is the end position. If we look at this next to each other with the actual maze, you can see more clearly where everything matches up. The final thing that the matrix does for us is allow us to easily find the position of Geo as he's moving, and what row and column he's in at a given point. That way we can determine if he can move to the next square in a certain direction or not move, or if he's reached the end or not. It's a really simple way. That way I don't have to worry about collision detection or something like event handling and fun stuff like that. Now, by using the matrix approach to creating the maze, it actually allows us to be able to, in the future, if we wanted, add randomization to the maze, just by scrambling the matrix, making sure there's a path to the end. As far as this game goes, it's finished. I'm not going to be doing any more development on it as far as in Matlab. If I decide to, I would probably put it in another game engine and actually add like little features and stuff, but that's only if I actually feel like doing that. Other than that, on the horizon, in the next episode, we can expect to go back to our Breakout game and look at Build 2. Like always, if you're on YouTube or Facebook, please leave a comment right down there. And if you're on YouTube, feel free to subscribe. Other than that, I hope you enjoyed watching, and I will see you next time.